Hello, everyone. Welcome back. So today we're going to learn about hyperbolas, another type of conic section. So our goals will be to essentially understand them. We'll find the vertices, foci, and asymptotes of a hyperbola. And we'll also be able to find the equation of a hyperbola in what's called standard form. We'll get into that. So if you've seen my other videos on conic sections, this is the last type of conic section we'll discuss. So if you have what's called a right circular cone, you have this basically end to end, like we have here. If you think about taking like a plane or think about a piece of paper and cutting down through these cones, you make what are called conic sections. If you cut straight across, you make a circle. You cut at an angle like this, you make an ellipse. It's kind of like a circle stretched out in one axis. Now, if you cut in such a way that you cut through the open part of the cone, that's called a parabola. And then if you cut straight down in a way that's parallel like through the axis of the cone itself, it makes essentially almost like two parabolas, or makes called a hyperbola. And hyperbolas and ellipses, as we'll see, there's some definitely similarities between them in the sense they have vertices, foci, and other similar features. And the equations are also very similar. So let's take a look at hyperbolas, and we'll start with some basic ones. And we'll also use Desmos to help us graph one. Let's come over here and start with our basic one, and let's do a simple one that has a center at the origin. All right, so some examples. So number one, let's do almost the most basic one, x squared plus y squared is equal to 0. Okay. Now, if you look over here to the left, this is taken from a textbook, and this basically gives us then our kind of most basic, or essentially our most general equation for hyperbola. Okay. So a hyperbola can have what's called a transverse axis horizontal or transverse axis vertical. Okay. So basically, the parabolas can go in this direction, left, right, or up, down. Okay. Now, how you tell the difference, and at first it may be hard, the easiest thing to tell is basically if essentially you have an x term minus a y term, it goes left to right. If you have a y term minus an x term, it goes up and down. So this one, oops, actually I realized I made a mistake. So this should be a minus, not a plus. Actually, that would have been an ellipse. So here, so basically the difference between an ellipse and a hyperbola as far as the equation is we have a plus instead of, we have a minus instead of a plus in the middle. Okay. Now, this one matches the first one. This one has a transverse axis horizontal. We're going to think about this kind of goes left to right. Okay. Now, let's pick out some other important features. Okay. Now, we also have a center, and we can actually find that. Let's pick out some of these numbers. All right. So if you notice, we're not dividing either x or y by anything. So A is equal to 1. B is equal to 1. Okay. Now we don't have an h or a k, including in the x or y terms. So that means that h is 0 and k is 0. Okay. So what can we get from that? What we can get from that then is that our center is just the origin, 0, 0. Okay. Now we can also find our vertices. Okay, and the vertices, it says are h minus a and k. And so the vertices are at so h minus a, that's 0 minus 1. Since h is 0, a is 1. 0 minus 1 and 0. K is 0. That goes to one vertice. Vertice is negative 1, 0. Okay. And the other vertex is h plus a and k. It's going to be 0 plus 1 and 0. And this means other vertex is going to be 1 and 0. And that makes sense. There's a symmetry there. Okay. Then we also have foci. It's like with an ellipse. And here, see, it says h minus c. Now here we need to find c. So I should do that next. Let's back up and let's find c. C squared is equal to a squared plus b squared. Okay. And that's equal to both a squared and b squared are 1, so 1 squared plus 1 squared is equal to 2. So that tells us that c is equal to the square root of 2. Okay, so now, then our foci, okay, for h minus c, remember h was 0, so 0 minus the square root of 2, and k, which is 0. And then the other foci, the other focus, is then h plus c, 0. And this then is positive square root of 2 and 0. Okay. And then finally, let's find our asymptotes. So this is something that a ellipse does not have. And to find those, once again, k, we have b and a are both 1. K and h are 0. So we have two asymptotes. As you see, we're going to have basically y minus 0 is equal to 1 over 1 times x minus 0. And so that's just going to be y is equal to x. And then the other one is going to be y minus 0 is equal to negative of that. And so that's going to be y equals negative x. Okay. Now let's also take a picture at our look at our picture. So once again, we have these essentially much like parabolas opening up left and right. So the vertices are these points right here. Lowest, in this case, the point for this one, furthest, your base of the points closest to the origin. And then the foci are these points out here, which are a bit off the parabola. And then we're kind of like a focus, much like a focus of a parabola. Okay. So finally, let's draw this, and then we'll take a look. Okay. So our center is at 0, 0. All right. We have vertices at 1, 0 and negative 1, 0. And then we have foci at square root of 2, 0 and negative square root of 2, 0. And then we also have asymptotes, y equals x and y equals negative x. And once again, those should be dotted lines here. So let me make that a little bit better. This is y equals negative, or y equals positive x, and y equals negative x on the other side. Okay, and so what happens then is that these hyperbola look something like this. Okay, so remember these are asymptotes, much like a horizontal, this is called an oblique asymptote. Basically, they're going to approach those lines without ever actually touching them. So basically, our hyperbola looks something like this. Well, let's actually graph that with Desmos. We can actually graph it just as it is. And so we can do x squared minus, make sure you do the minus, y squared is equal to 1. Okay. And so we can see that. So there are vertices. Okay. And then if we actually label then our, I guess I can label those. The first one. All right. Our foci is the square root of 2, 0. And then the negative square root of 2. All right. And then our asymptotes, y equals x and y equals negative x. And it's a little annoying because they put a red line there, but you see what happens. So these graphs approach, the curved parts approach those vertical, approach those lines without ever actually touching them. And that's our hyperbola. Okay, that's our first example. Now, let's actually just get rid of all that and start over. We'll look at our second example. This time we'll look at one with an axis that's vertical. I'll try and make one maybe a little more, a few different features. So give me just a moment. let's do one like this. So number 2, this one we have y minus 1 squared over 16 minus x plus 3 squared over 1 equals 1. Okay. Now, once again, let's compare this to what we see here. Now, clearly, this time, this one's not going to have a center at the origin. We'll get to that. Okay. Now, this time we have y minus x. So this is has a vertical transverse axis. So it opens up and down like the one at the bottom. So we'll focus on that one. Let's also pick out what our numbers are. All right, so it's going to look something like this. All right, let's find all our numbers. So h and k and everything. All right, so h is equal to number. Be careful here. So this x goes with h. So h, and also we have opposite signs, like we saw with ellipses and also with circles. So this is negative here, so h is positive 1. K is a positive here, so k is negative 3. Okay. Then also, remember our a is going to be the square root of this. So a is also goes under the first term in both cases. So our a here is going to be 4. And our b is going to be 1. Then we need to find c. So c squared is equal to 4 squared plus 1 squared. And that's equal to 16 plus 1 equals 17. And so c is equal to the square root of 17. And the square root of 17, just check your calculator. I won't bother going to Desmos for that. Let's see what square root of 17 is. About 4.1. That's close enough. Approximately 4.1. Okay. Now, from those things, then we can pick out our other important features. So our center of our ellipse is going to be h and k, so 1, negative 3. Okay. Our vertices, let's find those. So our two vertices, let's get down here. So h, which is 1, and it's k minus a. So negative 3 minus 4, and that's going to be 1, negative 7. And the other vertex is going to be h, and it's also going to be k plus a. So remember, k, negative 3 plus 4, and that's going to be 1 and 1. Okay, all right. Let's find our, go into our foci next. Squeeze those in right here. All right, so foci, so 1 is going to be h, which is 1. And k minus c, that's going to k, is negative 3 minus the square root of 17. Okay, actually, we'll just leave it like that for now. That is exact. And you can approximate that. And then the other one is 1, and then k plus c, so known as 3 plus the square root of 17. Okay, and then our asymptotes. Okay, and so we have y minus k. So y minus a negative 3 is equal to b over a. So, or sorry, a over b. A over b, so 4 over 1 times x minus h, or x minus 1. And then we can simplify that to y plus 3 is equal to 4 times x minus 1. And actually, you can also use Desmos. You can just type it in just like that, and we'll graph that. But if you're graphing calculator, you might have to solve this for y. Okay. And then the other asymptote, it should be exactly the same, except it's just going to be negative. So it's going to be y plus 3 is equal to negative 4 for our negative slope, then x minus 1. Okay, so those are our features then. Now here, I may not worry about graphing that by hand, though of course you can, But let's put all that in and let's kind of verify that, make sure that all works. Okay, let's go to Desmos. And so this one is y minus 1 squared. Oh, wait a minute. Hang on a second. I think I made a mistake. I apologize. Or maybe not. Oh, crap. I got those backwards. I sure did. You know what? Let's just do that everywhere. I think I did. You know, let's just turn this around. Let's just make this. I apologize, but that doesn't really matter. So it's this time, let's actually just change these because I've already calculated everything. Let's make this y plus 3. But I was being careful myself. And then x minus 1. So what happened was I took the h from here, which is not. H goes with the x, and the k goes with that. So now everything should be right. Yeah. Okay. So that's fine. So just make sure you make that correction if you want to do the same one. Now let's do that. Let's graph that. Yeah, as I said, be very careful of that. It's easy to make that mistake. All right. So I have y plus 3 quantity squared divided by 16 minus x minus 1 quantity squared divided by 1 is equal to 1. Okay. Oh, there it is. Okay. All right. That's what it looks like. So, um, good. It looks like have our vertices where they should 1, 1, and 1, 7. Let's double check that and make sure those are correct. So we said 1, 1, and 1, 7. Once again, after we changed it, we had 1, 1, and 1, 7. Good. 1, negative 7, rather. Good. We have that. All right. Our asymptotes, let's graph those. Let me write those down. Okay. And if we graph those, then so y plus 3 is equal to 4 times x minus 1. That looks like an asymptote. And the other one, I'm just going to copy this. The only difference, the other one, is just simply we have a negative in front of the 4. And yeah, that looks reasonable, right? Okay, so we have the correct vertices, we have asymptotes, so that's what that parabola, that's what hyperbola looks like. Okay, all right, let's take a look at a couple more ideas. Now, one thing you want to make sure you can do is you have one in a different form. So I want to find the equation in standard form. Okay, so let's take a look at a few examples, one or two examples of this. So what can happen sometimes, you can have one that's not quite in the form you want it to be in. Okay, so let's say you have something like this. Let's say you have 25x squared minus 16y squared is equal to 100. Okay, now obviously that's not in the form of either one of these. And so in order to put it in the right form, in order to find all our features we need to be able to find our vertices, asymptotes, and foci, we need to be able to do that. So what we're going to do then is we're going to divide. All right, so the first, let me say what we want is to look like, well, we know what we want. So we basically want it to look like one of these. And this one looks like it's probably going to have a center at 0, 0, which is good. But we want it to look like, well, that, like one we start with. Okay, so now what we're going to do is divide both sides by 100. That's going to affect dividing everything by 100. And so that's going to be 25x squared over 100 plus 16y squared over 100 is equal to 1. Okay, so that gets the 1 on one side. Now, we want to simplify these. At 25 over x over 100 becomes 4. So x squared over 4. Now, this one, 16, of course, it doesn't go into 100 evenly. We can take a 4 out of both. And that's going to be 4y squared over 25. Okay. Now, notice that's still not quite in, oops, that should be a minus, not a plus. It's still not quite in the form we want. Okay, so how do we get the form we want? Well, what we want to do is, when you think about what this is, basically, if I take this and I flip this, x squared over 4, and I can write this as y squared, and that's going to be 25 over 4 equals 1. And I'll see if that makes sense. So remember, you multiply by fractions. When you divide fractions, multiply by the reciprocal. If you multiply by the reciprocal, multiply y squared times reciprocal of this, which is 4 over 25, you get that. So that's exactly the same thing. Okay. Now, why do we do that? We want a final form, the form that helps us to get what we want. So now take the square root of both of these, which is square root of 4 is going to be 2 squared. And this, if you're taking the square root of the numerator and denominator, is going to be 5 halves equals 1. Now, in that form, then, we can now find all our h and k's, a, b, and c's, and everything, and then find all our features of our hyperbola. Okay, still, so let's make sure we put it in the right form. Now, the nice thing about a program like Desmos is you can actually graph it in this form, but then it's going to be a little bit harder to find those features from the graph. Okay, all right, let's take a look at another problem. This time, what we want is we're going to be given some information about the hyperbola, but we're not actually going to be told. We're going to be told, for example, like you can be told possibly like vertices and foci, or maybe asymptotes and foci, or asymptotes and vertex, something like that. Let's take a look at this. So we know we have asymptotes are y equals 3 halves x and y equals negative 3 halves x. Now let me make sure this is clear. This x is not the denominator here. Okay, what else we're told is that one vertex is going to be 0, 3. Okay, so one vertex is 0, 3. That's all we know. So what we want to do is find the equation. So let's take a look and see if we can figure out from these basic features what we have. Okay. Now, what we do know so far is that if you look at our first off, we're not sure which way this parabola goes at the moment, at least for asymptotes, goes this way or that way. All right. But what we can tell then, let's take a look at the equations of our asymptotes. You notice here, all we have are just the y and basically the slope and just the x. So we don't have any other constants anywhere else. What that tells us then is that h and k, no matter which one we look at, h and k are both 0. Okay, so that helps us to begin with. I'll say so h equals 0 and k equals 0. Okay, now let's take a look at our one vertex. All right, this is going to help us determine which equation, which type it is. Okay, so one vertex what we know is we're given one of our vertexes. The x-coordinate, of course, is 0. The y-coordinate is 3. So if we look at our vertices, okay, we already know that h is 0 and k is 0. Compare it to this and both of these, well, what we know then is that we said that k has to be 0. So it can't be this one, the top one. It can't be this one going left and right because k was 0. We have a 3 here. Compare it down here, it would have to be this case. Okay. So what that means then, okay, is that I'll say from the vertex, we have a horizontal, have a vertical transverse axis. So basically, we have this case right here because once again, our k we said has to be 0. And our k, if it was this case, our k would be our y-coordinate of our vertex. So we have, I can't write today, a vertical transverse axis. Okay. So our equation looks something like this. Okay. Y minus k squared over a squared plus x minus h squared. I'm sorry, I said plus. I meant minus over b squared is equal to 1. We already know a few things about this. All right. We know that, of course, h and k are 0. Now we know we have this case. What else do we know? Well, from the asymptotes, okay, what we know then from our asymptotes is we know that since we have this case, and once again, we don't have a k or h, asymptotes, then we have a over b. Okay. Notice here it's b over a. With this, no, in this case, a over b. And knowing that, then our a is going to be 3 and our b is 2. Now, actually, we also knew that from our one vertex. The vertex, since we're in this case right here, one of these vertices, since this is plus, is positive, since k is 0, also we can tell that a is 0 from that. Okay. So also mention that. Say, also a is equal to 3 from the one vertex. Okay. And actually, now we know everything we need because we know h and k and a and b. Okay. Let's say, so what we have is y squared over 3 squared, a squared, minus x squared over 2 squared is equal to 1. And then finally, we just have y squared over 9 minus x squared over 4 is equal to 1. Okay. Now let's take a look at that and see if that seems reasonable. Let's go back to Desmos. Let's do another graph. So let me erase these. So I said we had y squared divided by 9 minus x squared divided by 4 is equal to 1. Okay. Now vertices, so there's one vertex at 3. Here's other vertex at 3. Okay. So we should have an asymptote at y equals 3 halves x. Okay. That looks reasonable. And the other one is the same, just negative. So y equals negative 3 halves x. Yeah. There we go. Okay. Good. So that's an accurate equation. So let's take a look at what we've learned so far today. We've learned are just essentially the basics of hyperbolas. Okay, so hyperbola is a graph which mentions is a conic section, or if you cut, you want to take a piece of paper, cut across these cones, right down across like the vertical axis, you get these two parabola type features which are opening in opposite directions. And we saw basically what the equations look like. So you can have one essentially opens left and right. That's called a horizontal transverse axis. And you can have one that has a vertical transverse axis. Okay, so and also I may not said it specifically, but your center is not actually your center is kind of the center of the graph. It's not actually on the graph itself. Your center is here. Your vertices are the points closest to that center of your hyperbolas, and then your foci are on the outside of the curve, and they work very kind of similar to what you saw a focus with a parabola. If you have seen this one up for a parabola, so what we saw then is basically how to find then the vertices, asymptotes, and foci given the equation, and also the center. And also, for one centered at the origin, also not centered at the origin. We also have found how if you have an equation of a hyperbola like this, where it's not in standard form, how to put it in standard form in terms of the coefficients, then also how to put it, if you're given information, enough information about it in terms of asymptotes, vertices, and foci, then you can find the equation that way by finding h, k, a, b, and c. Thank you. Have a good day.